I saw this tweet yesterday from Simon where he said that using Promise.all will run your application's promises in parallel. So you can see here he has an example where we have 3 promises and we are awaiting each one of these promises. And then finally, we put all of these promises in an array and then we use Promise.all. And the essence of this tweet is correct. However, the issue is with this word parallel. Using the word parallel in this circumstance is technically incorrect. What Promise.all will do is run your promises concurrently. So what's the difference between running your code in parallel and concurrently? In this video, I'm going to explain the difference between concurrent and parallel and what happens when you use Promise.all to resolve promises. I'm going to try my best to not use any fancy language and confuse you even more. So I have this diagram here, and in this diagram we have 3 different execution paradigms. The first paradigm we have is sequential. So promise 1 will execute, we'll get the result from promise 1, promise 2 will execute, and then we'll get the result from promise 2. Secondly, we have concurrent, where promise 1 will execute, promise 2 will execute, and then we'll get the result from promise 1 and 2. And in Simon's example at the top here, this example at the top here would be considered sequential. So we're executing update user, and then we're waiting for the results of update user. Then we're going to update this send update notification promise. We're waiting for the results of this promise, and then we're going to send the cleanup logs promise. In the second code snippet here, where we're using Promise.all, this is going to run concurrently. So what does it mean when our code is running concurrently? So we're going to take all of the promises and we're going to execute them one by one. The word parallel means that we're going to execute the promises simultaneously. In JavaScript, we only have a single thread, except for some other circumstances that I'm not going to get into right now. And so this means that we can only do one piece of work at a time. So as JavaScript is executing the first promise, it doesn't necessarily need to return straight away, but it can only execute that one promise at a time. If JavaScript needs to wait for that promise to return, we can move on and execute the second promise. And finally, Promise.all will wait for all of the promises to be resolved before we return the results. If our code was to run in parallel, we could execute both the promises at once, and then we could wait for those results to come back. While parallel execution sounds better, concurrent execution is still much better than sequential. The differences between concurrent and parallel in practical terms is very minor, whereas the difference between sequential and concurrent can be quite significant. So let's have a look at some sequential code here. I have this sleep function 1, and then I have the exact same function, but this one is called sleep function 2. And you can see here that we're going to execute sleep function 1, and we're going to await that execution. Then we're going to console log this line, and then we're going to execute and wait for sleep function 2. And then finally, we're going to log to the console how long our functions took to execute. So I can put some breakpoints in here so we can see what is being called. And I can run sequential with the Node Debugger. So first up, we call sleep function 1. And you can see here sleep function 1 is called. Then secondly, we resolve sleep function 1. And then we're going to call sleep function 2. So you'll notice that sleep function 1 has been called and resolved before we execute sleep function 2. And then finally, we're going to resolve sleep function 2. And you can have a look in the console here. You can see we called sleep function 1 is called, then sleep function 1 was resolved, sleep function 2 was called, and then sleep function 2 was resolved. And it took about 7 seconds. This is because I have the debugger running. So let's have a look at our concurrent code here. We have the same 2 functions, sleep function 1, that is going to sleep for 1 second. And then we have sleep function 2 that is also going to sleep for 1 second. So in this example, we're using Promise.all. So now if we run this code with our debugger on, we can see what is going to get called when. So we can see here, as we'd expect, we execute sleep function 1. And then unlike the sequential example, we're going to execute sleep function 2. And then we're going to jump back into sleep function 1 because our timeout is ready to go. And we're going to resolve this promise. And then secondly, we're going to resolve the promise from sleep function 2, and we exit our program. Let's have a look what happened here. Sleep function 1 was called, sleep function 2 was called, and then sleep function 1 was resolved, and finally sleep function 2 was resolved. If we run these two examples without our debugger on, so I'll run node sequential, you can see that this function takes just over 2 seconds to run, which is expected because each of our promises is going to wait for 1 second each. However, if we execute concurrent, you can see that we take just over 1 second to execute this code. So if we swap these promises out for network requests, for example, and if we sent the first network request and then without waiting for it to resolve, we sent the second network request, we now have 2 network requests out ready to be resolved at once. And then as the network requests resolve, we can resolve our promises. So while JavaScript cannot execute code in parallel, it can execute it concurrently, and you can do that with Promise.all. Thank you for watching, and I'll see you in the next video.